Hello everyone, my name is Kjell Alving. I'm a professor of respiratory pharmacology at Department of Women's and Children's Health, Uppsala University, Uppsala, Sweden. I've been involved in exhaled nitric oxide research since the early 1990s, and I'm one of the co-founders of the former company Aerocrine that actually introduced exhaled nitric oxide measurement in the clinic. And I've been working on this methodology, both methodologically and clinically, ever since. So today I will try to answer some questions around FeNO and the NIOX VERO instrument. Well, I would say that the whole decade of the 1990s was used to was focused on standardizing FeNO measurement or exhaled NO measurement. And with the instruments we used at that time, the chemoluminescence instruments, we took into account also other aspects that we don't need to take into account when using more easy to use instruments like electrochemical sensor-based instruments. However, the first international effort to standardize the exhaled NO measurement was by the European Respiratory Society, and we published the guidelines in 1997. It was actually myself together with Sir Peter Barnes, United Kingdom, that published those guidelines, where we described the need to understand the exhalation flow rate and to control for that, and mouth pressure, the oral pressure, exhalation time, and also some specifications about the instruments. A couple of years later, the American Thoracic Society continued their discussions, also in an international effort with a lot of European scientists involved in the task force. And those guidelines, the first guidelines from the organized by the American Thoracic Society, they were published in 1999. And here the exhalation flow rate, 50 milliliters per sec, was described for the first time. So there was a consensus around that flow rate. Later on, 2005, slightly updated guidelines were published, again by American Thoracic Society, but there were only some fine-tuning from the 1999 guidelines. So we can say that the standard methodology has been settled since those years, and I was personally involved in all these task forces. Well, there are many factors that will influence the measured nitric oxide concentration in exhaled breath. The most important one is the exhalation flow rate. The higher the flow rate, the lower the resulting NO concentration will be, and vice versa. We also need to ensure that we don't get any contamination from the nasal airways, since we have very high normal concentrations of nitric oxide in the nasal airways. However, if the exhalation is performed against the resistance, so that the oral pressure is elevated during the exhalation, the soft palate or the velum will close, and excluding nasal NO from the breath sample. We also need to ensure that the exhalation is long enough so that the nitric oxide concentration reaches a plateau within the airways. If we exhale, well, if the exhalation is too short, we will underestimate the FeNO value. And of course, we need to take care of other confounding nitric oxide sources in ambient air, for example. So it would be prudent to inhale nitric oxide-free air. It's recommended. And of course, there are also some requirements on the instrument to be used with regard to detection limit and response times and so forth. Like for most diagnostic procedures, we need a standard technique, a standardized technique. Of course, it matters because we need to be able to compare measurements from clinic to clinic, from instrument to instrument. So all the instruments, they should comply with the recommended standardized method. And since we, at least up to now, we use generalized cutoffs, and the ones most commonly used have been issued by the American Thoracic Society. Of course, we need to use a standardized methodology so that the comparison with these cutoffs will always be the same, regardless of what clinic or what instrument. Alveolar NO has been in fashion for some years. We see nowadays quite few publications on that, more if we go back some years. I think one reason for that is that you really need to use a chemoluminescence analyzer, which is fast response, highly sensitive with a high resolution below 1 ppb and a sensitivity down to, well, 1 ppb, to be able to do the correct measurements so that you get an accurate calculation or estimation of alveolar nitric oxide. So for example, the European Respiratory Society technical standards from 2017 on exhale breath markers, they explicitly say that electrochemical or handheld devices should only be used for clinical FeNO 50 measurements and not for the multiple flow measurements for the estimation of alveolar NO. So we really need a chemoluminescence unit to do that, because the methodology claims that you use very high exhalation flow rates, up to 400 mLs per sec. This will produce very low FeNO levels, very low exhaled NO concentrations, way below 5 parts per billion. And it's extremely important that the NO concentration is accurately given in this range. Otherwise, the estimated alveolar NO will be faulty. We also have seen very little information in the literature about the clinical use of calculating or estimating alveolar NO. And it's, alveolar NO is really the flow-independent component of nitric oxide in exhale breath. Theoretically, that would be the starting concentration in the alveolar tract. But it's actually so that we have shown that there is a component coming from the mouth and pharynx that is also flow independent, probably due to the turbulent airflow in the mouth and pharynx. So some of the alveolar NO being estimated with these models originates in the mouth. So this is a confounding source. And we really don't know if it's actually an increased nitric oxide formation in the alveolar tract, or if it's a reduced uptake of NO in the alveolar tract, since we do inhale NO from from the central lower airways during a FeNO maneuver. There are data actually indicating that it's more of the latter, namely if alveolar NO is elevated, it's due to less uptake of NO in the alveolar tract. So I would say it's highly uncertain at this point if alveolar NO is really a marker of peripheral inflammation. It may be a marker of closed airways or aging airways, since alveolar NO has been shown to increase in elderly.